guys, welcome back to Kitabae, a place where we share our knowledge gained through reading that's eventually applied to analyze landmark events. Please note that this is ours, as in Team Kitabae's understanding based on various reports and resources. Hence, my sincerest apologies if any information mentioned here is inaccurate. Our humble thanks to the innumerable hours and relentless effort put in by the scientists at ISRO that warrant this post in Kitabae's hi-fi moments. So, are we ready to travel to space together? What is the brightest object in the night sky that illuminates our Earth at night? Yeah, it's pretty obvious. It's the moon. Till date, 20 missions to land on the moon have been launched, out of which 22 have been successful. India is now among the 5 nations to do what would have been impossible just 3 to 4 decades ago. A country that's just 76 years old is the first to land on the southern pole of the moon. India's mission to the moon on the South Pole is of special interest to scientists because of the occurrence of water ice in permanently shadowed craters. Permanently shadowed craters are craters that receive negligible sunlight throughout the day. Water ice, as I've read about it, is ice that's formed due to the direct freezing of fresh water or salt water. This water ice can be used to make rocket fuel. Water on the moon could also mean that a civilization existed millennia, maybe eons ago. This region is also rich in minerals like aluminium, magnesium and iron. Future explorers keep an eye out for the moon. It's not very surprising why the South Pole is the most sought after position on the moon by space agencies across the globe. Chandrayaan 2 is a perfect example that tells us to make the most of what is there and learn from it. I wouldn't say mistakes, but where there could be scope for improvement. Not to forget, Team ISRO had to face almost endless odds while designing and making a spacecraft. Chandrayaan 2's inability to soft land in 2019 did not deter the team at ISRO to give up, thanks to their commitment towards progress and the incredible quest towards knowledge. They made the most of the information received from the orbiter of Chandrayaan 2, which is currently still in motion. It has been instrumental in capturing high-resolution images, studying the moon's surface, and detecting water ice in the polar regions. This success reiterates ISRO's scientific and engineering capabilities. And as they say, never give up because great things take time. The team at ISRO analyzed what changes were required to successfully land at the south pole of the moon. This entailed that the lander would not again deviate from its trajectory, which happened during Chandrayaan 2, merely 2.1 kilometers away from the moon's surface. Team ISRO worked harder towards having more precise navigation, propulsion, communication, guidance through flawless software, improved technology, and vigorous testing. After all, सारे जहां से अच्छा हिंदू से था हमारा. Chandrayaan 3 soft landed on the southern pole of the moon on August 23rd, 2023 at 6:03 p.m. without a glitch. The entire world witnessed this spectacular feat, which is the first of its kind, not only in terms of landing on the south pole, but also making this possible at a modest spend of ₹600 crores. Christopher Nolan's latest movie, Oppenheimer, was more expensive to produce. Through this mission, India will not only access a sea of knowledge about the lunar surface, but also its likelihood for human habitation in the future. Well, we're not done yet. Chandrayaan 3 is slated to operate for one lunar day of 14 Earth days on the lunar surface. The lander Vikram and the rover Pragyan are modules that are equipped with advanced payloads. Since we've come to the topic, what are these payloads? Well, these are machines designed to perform a specific task. Chandrayaan 3 has 6 of these payloads. We will find out about many facets regarding the lunar terrain and its chemistry, minerals found there and their composition, the study of the moon's atmosphere, etc. The Pragyan rover will move around the landing site within a radius of 500 meters, which will tell us about the presence of water and other available resources. It will also conduct experiments and send data and images to the lander Vikram. The lander, in turn, will relay the data and images to the orbiter, which will then transmit them to Earth. How cool is that? It's time for some hot and fiery stuff now. Yes, you guessed it right. ISRO's satellite, Aditya, heads towards the sun on 2nd September 2023, India's first mission to study the sun. Aditya, meaning the sun in Sanskrit, embodies life through its energy. Scientifically known as a giant ball of plasma, the sun is located nearly 150 million kilometers away from us. A lot of thermonuclear reactions take place here. How does or how will it impact us? Well, that's exactly what the spacecraft Aditya will find out. Now, this gets us thinking about 1. How far can Aditya travel? 2. What happens when the Earth orbits around the Sun? 3. How will Aditya continue its research if the Earth is moving? And 4. For how long will it study the Sun? Well, Aditya will travel 1.5 million kilometers from Earth, which is 1% of the total distance from the Earth to the Sun, to reach the L1 position. How long will it take Aditya to reach the L1 position? Well, it's a 4-month-long journey to reach there. Wow! The thought of having something to stay in motion for 4 months. Yes, you heard me right, 4 months. That would take a huge amount of power. Now, let us learn about the 5 L positions. There are 5 points in space where objects, when sent there, tend to stay put. These points in space can be used by a spacecraft to reduce fuel consumption, to remain in position. These points, L1, L2, L3, L4 and L5, have been named after Joseph Louis Lagrange, a renowned Italian astronomer and mathematician in the 18th century. L1, L2 and L3 are known to be the unstable Lagrange points. However, the L1 point of the Earth-Sun system offers an uninterrupted view of the Sun, where Aditya will have the spacecraft SOHO's company. Aditya aims to stay there for 5.2 years. Now, let's dive deep into what all will Aditya find out and how will it help us. Aditya's 7 payloads aim to study the Sun's upper atmospheric layers, the chromosphere and the corona. This helps us to understand heating patterns, coronal mass ejections called the coronal rain, pre-flare and flare activities, study of in situ particles and much more. It is important to study the atmosphere of the sun, as it is the reason for sustaining life on the earth. The sun's magnetic activity and solar wind, along with gases flowing off the sun, cause space weather which may disrupt power grids, telecommunication and GPS system. Hence, it's better to be proactive rather than reactive. Imagine doing this mountainous task for a comparatively humble budget of Rs 400 crore. The shooting stars across many different cultures are symbolic of new life being formed. Certainly, such activities are a reminder that even in the vastness of the universe, we are all connected. A big thank you to ISRO once again. May the quest to knowledge continue. That's all from Kitabae for the moment. And remember, Kitabae before anything else.